Maike Schubert, researcher at SPF. I'm presenting the solar ice slurry systems. So solar ice slurry system is one of the two systems we are addressing in 3HP. As you heard before, it's more for the moderate or colder climates. We have ice storage combined with solar thermal collectors as a heat source for the heat pump. The solar collectors can also provide direct heat for the warm storages if the temperature level is high enough. And if it's lower, it's just loading the ice storage. The ice storage has some capability to provide some little cooling demands in summer. So enough for really moderate climates, but not thought for southern climates. And we are not using a reversible heat pump in this system. The heat pumps we're using in this system, you will see a presentation about that later. One is the CO2 heat pump thought for new buildings with a high share of domestic hot water demand, and one is the propane heat pump thought for the older buildings, the refurbished ones with lower share of domestic hot water demand. So solar ice system is kind of or solar combined with an ice storage is kind of an alternative source for heat pump systems if boreholes and or air is not wanted or not possible due to regulations or efficiency or similar things. And in principle, it acts in its long-term behavior like a ground source heat pump system with a full regeneration of the ground. And when we look to the costs, in 3HP we suggest not to use a conventional ice storage that has the heat exchanger within the ice storage, but a slurry storage. And this should reduce the costs of the overall system by about 10%. And so with this, we are in a range that is similar to the costs of ground source without regeneration, but it should be less expensive than a ground source system with regeneration, and regeneration is becoming more and more important. I will quickly show some results from a numerical study where we had the goal of looking for different climates all over Switzerland, or for different regions all over Switzerland, how this system works and how we have to scale it for reaching a seasonal performance factor of about 4. And there we ended up with a conclusion that we need about 0.6 cubic meters per megawatt hour ice storage size and 2 to 2.5 square meters per megawatt hour heating demand solar thermal collectors. And because these numbers are a bit difficult, I show here some examples. For example, for Bern, which is the capital city in the center of Switzerland, we need about 15 cubic meter ice storage size for a new building and about 90 square meters collector field. And of course, for an old building, we have to size it bigger. For a new one, we can size it smaller. And regarding the cost, this is one example with a comparison between the solar ice system and the ground source system. And we have the heat costs per kilowatt hour here. And we see that the solar ice system, but this is assuming a conventional ice storage, is a bit more expensive than a ground source system without regeneration. But with the ice slurry storage, it should be reduced by about 10%. And just as an outlook, currently we are testing this system and also the other system, the dual source dual sink system that Laura Alonso will present afterwards. We are testing those in a concise cycle test, so in a hardware in the loop test. And, oh, sorry. Can I go back? You can see here a sketch of such a hardware in the loop test where everything what is in the blue part, so with the blue background, is really installed in the laboratory, so the whole system is installed. It is controlled autonomously, it is running autonomously, and parts that are interacting with the environment or with the building, like the space heating, the PV modules, the thermal collectors, all this is emulated. So everything that is here shown in the gray part is simulated, emulated. And if you have interest in this topic, I will present this later in the CO2 energy session at about 10 to